This looks a little bit complicated, but it is actually very simple. If you observe, here the base is 2, here the base is 4, here the base is 16, here the base is 8. So all the bases are different. But what we can do in this situation is try to convert all the bases to be the same. And since 2 is the smallest base, let's see if we can convert 4 to base 2. 4 is the same thing as 2 times 2. So that means 4 is the same thing as 2 to the power of 2. What about 16? 16 is the same thing as 2 multiplied by 2 multiplied by 2 multiplied by 2. When 2 multiplies itself 4 times, you are going to get 16. That means 16 is the same thing as 2 to the power of 4. 8 is 2 multiplying itself 3 times. So 8 is equal to 2 to the power of 3. So instead of having 4 here, we can convert it to 2 to the power of 2. Instead of having 16 here, we can convert it to 2 to the power of 4. Instead of having 8 here, we can convert it to 2 to the power of 3. So let's do that. So this will be 2. What's the exponent of these 2? Does anybody know? Does these 2 have an exponent? And if it does, what is the exponent? 1, correct. So whenever you don't see the exponent there is 1, correct. So we have 1 times, instead of having 2 here, we're going to have 2 to the power of 2. But this 2 is going to multiply what was already here, a minus 3. Is equal to 16 is 2 to the power of 4. So we have 2 to the power of 4a divided by 2 to the power of 3 into 1 minus a. Next, let's try to eliminate this parenthesis over here. So we're going to have 2 to the power of 1 times 2 to the power of 2a minus 6 is equal to 2 to the power of 4a divided by 2 to the power of 3 multiplied by 1 gives you 3. 3 multiplied by minus a gives you minus 3a. So we have eliminated the parentheses. So the next thing we can do now is apply the law of the addition law that we have learned earlier, and then the subtraction law that we have also learned earlier. Addition law says that when you are multiplying two index numbers with the same base, you add the exponent. Subtraction law states that when you are dividing two index numbers with the same base, you subtract the second exponent from the first exponent. So this will be while maintaining just one base. So this will be 2. I'm going to divide this at this point. 2 to the power of 1 minus 2a minus 6. Does it make sense? So what we have here, we have reduced it to this point. Does it make sense to everybody? Oh, thank you. It's plus because multiplication. That's why I have this phone over here so I can see in case I make a mistake along the way. Thank you, guys. Equal to 2 into 4a minus 3 minus 3a. Okay. So next, let's eliminate this bracket here. So plus times plus will give you plus. So we have 2. We have 1 plus 2a. Plus times minus will give you minus. So we have minus 6. Is equal to 2, 4a. Minus times plus will give you minus. So we have minus 3. Sorry, minus times plus will give you minus. Yeah. And then minus times minus will give you plus. So we have plus 3a. So now we can add like terms or subtract like terms. So 1 minus 6 is going to give us minus 5. So we have 2 to the power of 2a minus 5 is equal to 2 to the power of, here we have 4a plus 3a, that will give us 7a. So we have 2 to the power of 7a minus 3. So at this point, now we can apply what we already know. When the bases on both sides of the equation are the same, you equate the exponent. So this would be 2a minus 5 is equal to 7a minus 3. So we move similar terms to one side of the equation. So we have 2a minus 7a is equal to minus 3 plus 5. 2a minus 7a is going to give us minus 5a. Is equal to minus 3 plus 5 is going to give us 2. Okay. Okay, so let's conclude with this. So we have minus 5a is equal to 2. That's what we have. So if we divide both sides by minus 5, A, this will cancel out. This A will be equal to, there's an invisible plus sign here. So plus divided by minus will give us minus 2 all over 5. And that becomes the value of A.